Today, we are embarking on a journey to explore some truly captivating tourist destinations. But we are not talking about your typical vacation spots here on Earth. No, we are setting our sights much farther, to the red planet itself, Mars. Get ready for an out-of-this-world experience as we uncover some of the most intriguing and otherworldly destinations that Mars has to offer. So strap in, because this is going to be one cosmic adventure you won't want to miss. Olympus Mons stands as a towering giant on the Martian landscape, reaching staggering heights of approximately 25 kilometers above the surrounding plains. To put that into perspective, it is nearly 3 times the height of Mount Everest, the tallest peak on Earth. Its immense size and scale make it a sight to behold, dominating the Martian horizon with its majestic presence. But what sets Olympus Mons apart isn't just its height, it's also the sheer breadth of its volcanic complex. With a diameter stretching over 600 kilometers, this colossal shield volcano covers an area roughly equivalent to the state of Arizona. Its gently sloping flanks extend outward in all directions, creating a massive footprint on the Martian surface. The origins of Olympus Mons trace back billions of years to a time when Mars was a much more geologically active planet. Unlike the stratovolcanoes found on Earth, which form from layers of solidified lava and volcanic ash, Olympus Mons is a shield volcano, characterized by its broad, gently sloping profile. This shape suggests that lava flows played a significant role in its formation, gradually building up layer upon layer of volcanic material over millions of years. Unlike Earth, which has tectonic plates that constantly shift and reshape its surface, Mars lacks such active plate tectonics. Instead, volcanic activity on Mars is thought to be primarily driven by hot spots, localized regions of upwelling magma beneath the planet's crust. As magma rises to the surface, it erupts through fissures in the crust, creating vast lava plains and volcanic constructs like Olympus Mons. Despite its colossal size, Olympus Mons is also relatively young in geological terms, with estimates placing its age at around 200 million years. Let's embark on an exploration of the Tharsis volcanoes, a remarkable volcanic region on Mars. The Tharsis region is located near the Martian equator and is home to some of the largest volcanoes in the solar system. The towering giant, Olympus Mons, is within this region. What makes the Tharsis volcanoes so fascinating is not just their size, but also their geological significance. Unlike traditional shield volcanoes found on Earth, which are typically isolated features, the Tharsis volcanoes are part of a vast volcanic complex that spans thousands of square kilometers. While the Tharsis volcanoes are currently dormant, evidence suggests that volcanic activity may have been more widespread in Mars's distant past. The presence of vast lava plains and extensive volcanic constructs across the region points to a history of intense volcanic activity that may have played a crucial role in shaping the Martian landscape. Another fascinating geological wonder is known as Vales Marinaris. It is a colossal canyon system on Mars that stands as one of the largest and most remarkable features in the solar system. Vales Marinaris stretches across the Martian surface for over 4,000 kilometers, making it roughly 10 times longer than the Grand Canyon on Earth and up to 7 kilometers deep in some places. This immense canyon system dwarfs anything found on our home planet and serves as a testament to the dynamic geologic processes that have shaped Mars over billions of years. The formation of the canyon is thought to be linked to tectonic activity and volcanic processes that occurred early in Mars's history. Scientists believe that as the planet cooled and its crust contracted, enormous rifts and fractures began to form, eventually giving rise to the sprawling canyon system we see today. One of the most striking features of Vales Marinaris is its complex network of interconnected valleys, cliffs, and plateaus, which provide valuable clues about the geologic history of Mars. The canyon walls exhibit layers of sedimentary rock, evidence of past water flow and erosion, suggesting that Vales Marinaris may have once been the site of ancient rivers or even an ancient ocean. But perhaps the most captivating aspect of Vales Marinaris is the sheer scale of its dimensions. The canyon system is so vast that it could easily swallow entire mountain ranges on Earth, and its depths plunge to depths deeper than the Mariana Trench, the deepest point in Earth's oceans. Vales Marinaris is also home to a diverse array of geological features, including landslides, volcanic cones, and ancient river channels, all of which offer valuable insights into the planet's geologic past. Studying these features provides scientists with important clues about Mars's climate, hydrology, and potential for past habitability. The north and south poles of Mars are captivating regions that offer unique insights into the planet's climate, geology, and potential for past and present water activity. Unlike Earth's polar ice caps, which are primarily composed of water ice, the polar ice caps of Mars are predominantly made up of frozen carbon dioxide, or dry ice, along with a mixture of water ice and dust. At the North Pole of Mars lies a vast expanse of ice known as the North Polar Ice Cap. This ice cap spans an area roughly the size of Greenland and is composed mainly of water ice covered by a layer of seasonal carbon dioxide frost. During the Martian winter, temperatures plummet, causing carbon dioxide to freeze out of the atmosphere and form a thick layer of dry ice on the surface. As spring arrives, the carbon dioxide sublimates back into the atmosphere, leaving behind a landscape of water ice and dust. The South Pole of Mars boasts a similar ice cap, known as the South Polar Ice Cap, although it is slightly smaller in size compared to its northern counterpart. Like the North Polar Ice Cap, the South Polar Ice Cap experiences seasonal variations in its ice cover, with carbon dioxide frost forming during the winter months and sublimating away during the warmer seasons. In addition to their icy landscapes, the polar regions of Mars are also home to unique geological features, including polar layered deposits and polar troughs. Polar layered deposits are extensive layers of ice and dust that have accumulated over millions of years, providing valuable clues about Mars's past climate history. These layers contain a record of seasonal variations, similar to tree rings on Earth, which scientists use to study past climate cycles on the Red Planet. Polar troughs, on the other hand, are deep valleys that cut through the polar ice caps, likely formed by a combination of erosion and tectonic activity. Now let's delve into the mysterious world of ghost dunes on Mars. Ghost dunes are the remnants of ancient sand dunes that once dotted the Martian landscape billions of years ago. These dunes, sculpted by the wind, were similar in appearance to the sand dunes found in deserts on Earth. However, unlike their earthly counterparts, which are often preserved by ongoing sand deposition, the Martian surface has undergone significant changes over time, leading to the burial and preservation of these dunes in the form of ghost dunes. The process of fossilization begins when the sand dunes become buried under layers of sediment or volcanic ash. Over time, these layers harden into rock, effectively preserving the shape and structure of the dunes beneath. As eons pass, erosion gradually wears away the surrounding rock, exposing the ghostly outlines of the buried dunes for all to see. In recent years, researchers have used high-resolution images from orbiting spacecraft, such as NASA's Mars Reconnaissance Orbiter, to identify and study ghost dunes across the Martian surface. These images reveal intricate details of the dune fields, including their size, shape, and spatial arrangement, allowing scientists to reconstruct the ancient environments in which they formed. Ghost dunes represent a fascinating chapter in Mars's geological history, offering a glimpse into the planet's ancient past and the forces that have shaped its surface over billions of years. As our understanding of these enigmatic formations grows, so too does our appreciation for the dynamic and ever-evolving nature of the Martian landscape.